Hello students, welcome to the session of Interferometer. We will be dealing with the following contents of interferometry, such as the principles, sources of light, optical flat, fringe patterns, and the related instruments for measurement which are based on light sources like toolmaker's microscope and profile projector. This is the distribution of question and with its marks. So coming to the introductory part, we know that light is an electromagnetic wave and which is nothing but a sinusoidal form, and with that we also know that it contains some low points and high points, which we call it as trough and crest or roots. So light waves are very much useful for many types of measurement, with we can say that which provide us error free measurements. So the phenomena of interaction of light waves is known as interference, and the instruments which are based on this principle is called as interferometer. Likewise, so light source used for interferometry, specifically which type of light source is used for interferometry, we can say that the light such as mercury, helium, sodium, thallium, specifically which provide us the monochromatic light source. That is, monochromatic light is nothing but a white light which contains whole spectrum of wavelength, and with that the pitch of interference fringes. I will be dealing with fringes, what it will be. So from different from each other. So following conditions should be satisfied for that. So first one is the two light sources should be coherent. This will be our first condition, and second is the two sources should continuously emit light waves of same wavelength and same frequency. So this is most important, and for obtaining this interference fringes, the amplitudes of two interfering waves should be equal. So following will be the conditions for using this light source. Again with that, so as we know that what are the different light sources, this one, and it specific light source has some sort of specific characteristics, so we'll not go in detail of that, but timing we can know that sodium, helium, mercury, gas laser, thallium, cadmium, krypton, following light sources has some specific characteristics, such as suppose if we consider sodium, so it is used for interference path difference and yellow sodium light, which is containing the separate closely spaced lines and equal intensity. Likewise, if we consider mercury, which has a high illumination intensity and which is very less expensive. So from all of this, the most we can say that used is mercury, popular is mercury, and then other provide this. So we can continue with the snapshot of this. Next one, now specific instruments related to light source. We call these instruments as interferometers. So what are this? They are the optical instruments used for measuring flatness, determining the length of the slip gauges by direct reference to the wavelength of light. But again with that, it overcomes some drawbacks of optical flat used in ordinary daylight. That is, in these instruments the lay of optical flat can be controlled and the fringes can be oriented as per the requirement. So we can adjust the length, thickness of the fringes as per our requirement. So optical instrument. Now what are specific optical instruments which provides us the information or which has the contribution about the information capturing, measuring and the machining process. But with that, due to development of some of the optic or optoelectronic devices, it promotes development of precision optics, mechanics and electronics. That is, combination of some of the part we can get with this. Now various factors which are responsible for the development of optics are as first one, fiber optics, material structuring, development and application of lasers, coherent optics and computer assist or optic designs, and availability of new medias. Now before dealing with the detailed part, some basic terms as we all know, but with that again we will give for. When we go for using interferometer, we should understand what are the dark phases or fringes, we'll say, and what are the bright fringes. So suppose we consider two waves of light A and B. Suppose these two are in phase. When both are in phase, that means suppose this part. So what will be the resultant part will be our additional, that is combination of these two, and which will provide us the bright amplitude, that is brightness, or in our interferometrical terms we'll say that it provide us the bright fringe. Whereas when two waves, that is suppose C and D, are opposite in phase, this one, so we'll say that the resultant amplitude will be 0 and the resultant will be a straight line, or we can say in our interferometer language it will show us a dark fringe. Next one. Now what are the different types of optical flats? Optical flat is nothing but one of the material of quartz and an instrument used for observing the fringes. So there are two types you can say. First one is type A and type B. Type A, only what is the difference important you have to understand is only one surface is flat in this case, and both type of surfaces are flat in type B. So nothing to understand from this part, but to remember is only one surface is flat, other surface or both surfaces are flat in this case, and both has accuracy of 0.0 micrometer, and are all available with some of the grades. We'll discuss this again. Next one, interference bands. Now how this interference bands, that means what I was talking about is nothing but this. Suppose we can say that this is the optical flat, this part is an optical flat, one circular part we can say, and when light source is incident over here or over here, same, so some sort of dark fringes or bright fringes, dark fringes or bright fringes are observed, what I was talking up till now. So this is nothing but due to the interference of two lights, that is suppose in phase will get bright and suppose out of phase will get dark light. So this is the principle. Now how it occurs, suppose ray AB is incident on optical flat, it will interfere, refract through this to BC, CF and FG will be its first path, and again it will move in this case, but at the same time another same ray will be reflected, some part of that, or we can say partial light will be reflected through this bottom surface of optical flat. So due to this what will happen, we'll get two reflected light, or some part will be refracted over here. So what will happen, if the distance between these two is odd or even, based on that the wavelength difference or path difference will get the dark and bright fringe, and that will be nothing but important thing to observe the fringes, there should be some sort of inclination for this, and obviously this is available due to the surface irregularity. Now so what I told now is nothing but the observation of fringe patterns from this side. So that is what I was talking. If the path length differs by odd number, that is lambda by 2, then interference said to have occurred. And if the surface is perfectly flat, then that means no cross fringes, so alternate light and dark, which will be only dark or either this. Now what I, based on the shape of the fringes, will get, or we can identify what type of surface it is. So two examples are shown over here. Perfectly flat will show straight lines on the optical flat, whereas not flat, may be convex, concave or valley type, will show some sort of spherical or circular pattern. So based on that we can identify this. Same case, suppose if it is a spherical, we'll get circular pattern. If it is a flat, we'll get straight line. If it is ridge or valley, we'll get conical, or say for cylindrical, very bright, or with a curve on for this. Likewise for convex and concave. So from the center part, the light will be moving outside, it will be a convex, and if the light moves towards the center, we can say that it is a concave part. And same, how will be the placement of this will be in this fashion. If it is a convex or concave, you have to place this, and this part will be nothing but the inclination part. Based same example. Now checking one example, that is parallelism. Now what we can say is, this is a standard component, this is the gauging which we have to measure, and for getting this difference h, that's why these two components are placed on a surface which is perfectly lapped or finished. So two components you have to place, one will be a gauge, we can say slip gauge, and one standard as for reference. So there will be some sort of error, and that error is nothing but h, and that h will be nothing but which will provide as the inclination. Based on that we have to measure. Now how the optical flat light source will be working, it is based on the same principle of microscope. That is, over here light source will be there, which will be monochromatic as we discussed. Again with that condensing lens, through that light will be passing and it will be incident on the mirror. Mirror will reflect the light, and through the collimating lens parallel light rays will be converted and it will be directly incident on the component gauges or whatever is placed over there through the optical flat, and the reflected light again will move back and will be collected through a eyepiece and will get the fringes or fringe pattern over here, and based on that we can identify the type of surface, whether it is convex, concave, or either cylindrical or trough. Next, this was the basic principle, first type interferometer. Now next one is the Npl Peter Interferometer. So what is the difference in this is only the constant deviation prism is provided over here for getting the straight parallel lines from a light source. In earlier case only lens was present, over here we have constant deviation prism which will provide us the direct incidence of light. Other components will remain the same, the reflection part, and directly we can observe the fringe pattern over here. So some of the equations related to fringes we will be discussing in detail in other videos again. Same thing is shown, what will be the difference, when will get the bright fringe, when will we get the dark fringe, based on these equations. Likewise the linings will be generated based on the distance, based on the theta angle, and how many fringes will be observed, that is n, based on the light principle. The application of interferometer, or very important application, is the profile projector. Profile projector is one instrument which is based on same light principle, but it directly provides us the image of that. Only difference in interferometer and profile projector is that it passes the light from the light source through the lens and all parts related to that, but instead of eyepiece, the image will from the mirror will be directly provided on the screen and will get the image. This is the very popular instrument used for measurement of some of the parts like screw measurement, gear measurement, and whatever sizes based on the shadow principle. So very popular instrument. We'll be dealing with our practical videos of this profile projector. Same thing based on this. Thank you.